Hello friends, and welcome to the lecture number 3 of the basic course on engineering circuit analysis. So today we are going to cover an important topic in which we will be discussing about the concept of voltage, and we will be discussing the concept of voltage on how you have to understand voltage with respect to engineering circuit analysis. So let's begin. We will begin with the basic understanding or the basic definition of voltage. You might already have read about this, but this will be a slight recap. So you know that whenever you are having a charge, for example, you are having a charge, say Q0, and it is resting at a point A. If you are moving this charge from the point A to point B, there is some work associated with that. You have to do some work in order that the charge moves from point A to point B. Okay, so what is voltage? The voltage is actually a measure of this work being done. We all know that voltage is actually the work done per unit charge. You might have already seen this expression where voltage is defined as the work done per unit charge. So voltage is the work done in moving charge from one terminal to another. So if you, in terms of engineering circuit analysis, for example, you are having a circuit element and the charge is moving from this terminal to this terminal. So voltage is the measure of the work done in moving that particular charge. The formal definition is voltage is the work done per unit charge. So what is the unit of voltage? The unit of the voltage is volts, or you use the capital letter V to represent the voltage. So for example, you are having 1 volt, you write it as 1V, 1.5 volts, 3 volts and so on. So this is the representation of voltage. Now the most important point in representing a voltage is this point here, and we will be going into considerable detail in understanding this point. Voltage has both magnitude and polarity. So this is most important in understanding the representation of voltage. That is, the voltage has both magnitude as well as a polarity. So if anyone wants to represent a voltage, usually they do like this. So for example, you are having a circuit element. Let's call it as circuit element 1. It has two terminals A and B with which we can interact with the circuit element. So the usual representation is like this. They will put a plus and minus sign and they will represent the voltage here. Okay, so this is the conventional representation of a voltage. So this polarities that I have put here, this plus and minus sign, is the polarity of the voltage. The polarity of the voltage, and this V, or let me call it as V1. V1 is the magnitude of the voltage. V1 is the magnitude of the voltage. See, now I have drawn this circuit element as a black box here. But remember, this is just a representation. This circuit element 1 can be part of a larger network like this. For example, you are having a simple circuit like this. Of course, you don't have to worry about this circuit now because we will be seeing a lot of circuits like this in the future. For the time being, let us just notice this circuit element 1. So this circuit element 1, let us mark two terminals here, A and B. So this A and B which I have marked here is this A and B here. Okay, and the representation of voltage will be something like this. So I have put plus terminal to A, minus terminal to B, and a magnitude of V like this. Okay, so just remember the fact the circuit element might not be a black box, but it might be part of a complex network like this. This representation is given to you so that you can understand the concept in a much better manner. Now if I simply give you the circuit like this, okay, if I just give you a circuit like this without anything, okay, so you don't know the voltage and you don't know the polarity. So basically, if I give you a simple circuit like this with circuit element 1, you see that the voltage is unknown. The voltage is unknown, as well as the polarity is also unknown. These two quantities are unknown. So what will you do to find out the voltage and find out the polarity? So for this case, you will use a voltage measuring device, right? You will use a voltage measuring device. Now follow closely. The conventional instrument which is used to measure voltage is a voltmeter. So the voltmeter can measure voltage. But usually there is another instrument which is called a multimeter. Now a multimeter can measure voltage, it can measure current, it can measure, say, continuity, it can measure capacitance. There is a lot of things that a multimeter can do. It can measure resistance. So multimeter is a versatile device. So let us take a multimeter and try to get a little bit more understanding on the concept of voltage. So how does a multimeter look? A simple multimeter looks something like this. You are having a display like this. So the display can be analog, In older multimeters, the display used to be analog, or nowadays you find that most of the multimeters are digital. And the most important thing is that there are two leads available here. One is positive and one is negative. There are two leads, one is positive and one is negative. And you can use these leads to connect the multimeter to the circuit element. Okay, so you are having a positive lead and you are having negative lead, and these leads you can connect to the terminal A or terminal B as per your understanding of the circuit. Now that you have seen the representation of voltage and you are having a multimeter with you, let us see how this polarity and magnitude is written. So let us take a circuit element, take a random circuit element 1, something like this. It has two terminals, like earlier case, it has two terminals A and B. And now you are having a multimeter with you. Okay, you are having a multimeter with you which can display a voltage which has a positive lead as well as a negative lead. Now look closely what I am going to do. I am going to connect the positive lead of the multimeter to terminal A. Okay, I am connecting the positive lead of the multimeter to terminal A like this. Okay, I have connected the positive lead of the multimeter to terminal A. Now I am going to connect the negative lead of the terminal to the terminal B. Negative terminal of the multimeter to terminal B. So once I do this connection, I should put a positive polarity here and a negative polarity here. Why positive here? Because positive is connected to A. Why negative polarity here? Negative is connected to B. Okay, so that is this positive and negative. And once you do this connection, you will get a voltage in the display. You will get a voltage in the display. We can call that as a measured voltage of the multimeter. Measured voltage by the multimeter. So for example, that value is V1. Okay, that value is V1. You get the display value as V1. So that value I will put here. So this drawing which I have drawn is actually this circuit which I have seen. Okay, I have in this circuit what I have done, I have connected the positive lead of the multimeter to terminal A, the negative lead of the terminal to multimeter B, and I have measured a voltage of V1. Okay, so I'll just write that down here. So the conclusion is the polarity is actually the connections made by the multimeter. The connection made by the multimeter. Okay, and the magnitude is the value of voltage measured by the multimeter. I hope things are clear. Now let us take another circuit element. Let us call it as circuit element 2, CE2. This also has two terminals, say A and this is B, and CE1 and CE2 are two different circuit elements. So again you are having a multimeter with you. Okay, this is your multimeter and you are having a positive lead as well as a negative lead. Now look closely what I am going to do now. So the positive lead of the multimeter, I am going to connect it to the B terminal here. Earlier I had connected to the A terminal. Now I am connecting it to the B terminal. And the negative terminal of the multimeter, negative lead of the multimeter, I am going to connect to the A terminal here. Okay, so once I do that, look closely, because positive I have connected to B, I will put a positive sign here, and negative I have connected to A, I will put a negative sign here. And for example, I measure a voltage V2, I get a V2 voltage in the display. I will write it as V2. Okay, so in this case, the multimeter positive was connected to the B terminal, the negative was connected to the A terminal, and the measured voltage was equal to V2. So I have told you, it is not a must that you should always connect the positive to A and negative to B. No, it depends upon how you decide to connect the circuit. Now the important thing here is that the value of V1 or the value of V2 based on your connection can be positive, negative or 0. Similarly, V2 can be positive, negative or 0. This actually depends on the connection of the multimeter with the terminals A and B. I'll write down that, with the terminals A and B, and the actual behavior of the circuit. Okay, and the actual behavior of the circuit. This point we will be going into a great detail in the next video, because understanding this topic is very important in understanding almost all circuit related subjects. So as a conclusion, let us just write here. So if you have a circuit element 1 here like this, Okay, you are having your circuit element 1 with two terminals A and B, and I am writing something like this, plus or minus V1. What does this mean? This means that the multimeter positive was connected to the A terminal because positive is given to A. The negative is connected to B terminal, negative is connected to B, and the measured voltage by the multimeter is V1. Okay. And for example, you are having a circuit element 2. Okay, this is your circuit element 2 here. So this also has a terminal A and terminal B. And for example, I am writing the voltage as plus or minus V2. Okay, so in this case, what does this mean? The multimeter positive was connected to B, multimeter positive was connected to B, multimeter negative was connected to A, and the measured voltage as seen by the multimeter was V2. And V1 and V2 can be positive, negative or 0 depending on these connections.